In my previous videos, I taught you how to find the equivalent fractions, decimals and percentages when the denominator of a fraction was something like 10 or 100. Today I'm going to teach you how to do this when it's slightly trickier looking numbers. So, for example, if we've got something like 2/5. Now, the denominator here isn't 10, and in the previous video we talked about having a place value chart like this, where we had a tenths column and a 100ths column, and then obviously a units here. And we were just placing the numbers into our column whenever there was a denominator of 10 or 100. Unfortunately here, there isn't a denominator of 10 or 100, but it's 5. That's okay. Instead, we can think about what we can do to the denominator 5 to turn it into 10 at the bottom. Now, in this case, you multiply it by 2. And with all fractions, whatever you do to the denominator, you must do to the numerator. So we multiply the denominator by 2 to get to 10. So we must multiply the numerator by 2 to get to 4. So we're left with 4 over 10. Now, because the denominator here is 10, and there's a denominator in our place value chart over here of 10, we simply just put in our numerator 4 into that column in the place value chart. So we're left with 0.4. And again, when we're talking about percentages, our place value chart column, which is important, is this one. That's our percentage, so the 1 over the 100. That's code for percentage, so you put in a placeholder of 0, which leaves you with 40 over 100, or 40%. Now again, that works really well when you've got numbers that go into 10 or go into 100 really easily. But sometimes you've got numbers like something over 7, like for example, if we were to have 3 over 7. Now 7 doesn't go into 10 or 100, so we're facing a bit more of a problem here. So what I'd like you to think about here is what that fraction line actually means. Now what that fraction line means is divide. So 3 over 7 is the same as saying 3 divided by 7. Again, that looks really complicated. So let's think back to our knowledge of bus stop division. So what that's saying is how many 7s go into 3. So if we write that down as a bus stop, we've got 7 on the outside and 3 on the inside. Again, that looks really strange, doesn't it? But it's okay because we can just place a decimal point here and then a number of zeros after the decimal point, just until we've just so we can start to figure out what decimal it might turn into. When doing bus stop division with decimals, you have to think about that decimal point and think, okay, it needs to go up to here as well. So before we've done any maths, we know that the decimal point is going to be in a straight line there above the line. So, first question, how many 7s go into 3? Well, 7's bigger than 3, so the answer is 0. But we've got 3 left over, so we can carry our 3 to here. So our new question is, how many 7s go into 30? So if we count up in our 7s, we know that 7 times 4 is 28, leaving us with 2 left over to get to 30. So that 2 left over goes here before the 0. So now our new question is, how many 7s go into 20? Again, this time we count up in our 7s, 7, 14, that's the closest we can get to it. So 7 times 2 is 14, with a remainder of 6 to get to 20. Again, we're now looking at how many 7s go into 60, and that's 7 times 8 is 56, with a remainder of 4. And then it goes on and on and on, so we can then go how many 7s into 40, and we know that that's 5. And we sort of stop there because this is a number that will go on and on. So at this point, usually you'd probably do 2 decimal places, maybe 3 decimal places. So for 3 7s, I think we should do it to 3 decimal places. So we then look at the 4th number after the decimal point, which is our 5. If that's 5 or above, then that means that the 8 goes up. And if it's 4 or below, it means that it stays as an 8. So in this case, because it's 5, if you're to write that as a decimal to 3 decimal places, we know 3/7 is the same as 0.429, and I'm going to write here to 3 dp. So there's my top trick, really, when you've got tricky fractions, is to just think of it as a division sign, that fraction line, and just work it out from there. Okay, I'm going to quickly do one more for you, and you feel free to pause the video and give this one a go yourself if you'd like to. So for this, let's just go with 2/9. Again, as I said, pause the video if you'd like to now, otherwise I'll work through it. Okay, so what's this asking? Well, this is asking how many 9s go into 2. So again, before I do any of the maths, I just will put my decimal point there, a bunch of zeros, and I'm going to bring up my decimal point above the line so it's in the right place. So how many 9s go into 2? Again, 0, we'll carry our 2. Now it's how many 9s go into 20? Well, 9 times 2 is 18, we'll carry our 2. And you'll start to notice that it's looking like it's going to be how many 9s go into 20 every time. So if we going over to this one, it's how many 9s go into 20 here. Again, 2, remainder 2, 2, remainder 2, and that's going to go on and on and on forever. So 2 9s is the same as saying 0.2 recurring, and you can see I've put a dot over the 2s to show that it's recurring, which means that the 2s will go on forever. You could also write it with a line on top of it like that. It means the same thing. Okay, I hope this was useful. And yes, just always remember that fraction line is just another way of writing division.